For astronomers, the new century was looking to be an interesting one in 1999. If all went according to plan, there would be discoveries of exoplanets, new Mars rovers, and groundbreaking research on a newly built International Space Station. Nobody, however, was planning on the new century beginning with a riddle that would take longer than 2 decades to solve. Then, in January 1999, satellite images of a solar flare showed something peculiar. It appeared that dark spikes were emerging from the flare and traveling slowly downwards toward the Sun. And it wasn't until 2021 that scientists discovered the reason for it. Now that solar flares have been studied by scientists since 1859, we are quite familiar with them. In essence, they are enormous bursts of radiation caused by the Sun's magnetic field lines twisting and suddenly releasing a rush of magnetic energy. When that occurs, plasma and bright light, or superheated gas particles, drift away from the Sun. Additionally, these outbursts can occasionally interfere with communications and electrical networks if they occur in our general vicinity, unlike many astronomical phenomena that have no direct impact on our existence. To keep a watch on things like these, telescopes are continually tracking the Sun's activity. Additionally, as telescopes have improved, they have allowed us to see solar flares with increasing clarity. Scientists researching solar flares in the years before 1999 discovered that certain flares had a kind of dark fringe surrounding them. It wasn't until that year, however, that scientists received observations from the Japanese Yohkoh spacecraft, which showed how the matter was traveling in these outskirt regions. Things started to become intriguing at that point. According to the observations, the dark region's plasma was falling as the solar flares erupted higher. Scientists at the time had a hypothesis as to why this might be occurring. They postulated that the magnetic field lines were involved. It's kind of like cutting a bunch of tightly tangled ropes. You see, when magnetic field lines that have been twisted up release a lot of energy. The magnetic field lines or ropes untangle the tangle and settle into a new arrangement. Magnetic reconnection is the scientific terminology for this. The flow of plasma also changes as a result of the shifting magnetic field lines. Therefore, the research team that produced the 1999 finding proposed that magnetic reconnection was what caused the downward flowing zones. However, there was one puzzle piece that wasn't quite right. These downflows, also known as SADs or supra-arcade downflows, were gradual. The magnetic reconnection hypothesis-based simulations and real-life findings made by scientists were highly contrasting. Downflows in real life were consistently slower than the models. For more than 20 years, this left scientists perplexed and looking for an alternative explanation for these slowly moving plasma flows. A team of astronomers from the United States used data from NASA's Solar Dynamics Observatory to investigate this. They collected information on solar flares that experienced these enigmatic downflows. Following that, they created some 3-dimensional models of solar flares and compared them with the observations. Once more, they concluded that magnetic reconnection couldn't possibly account for what they observed in reality. But when the researchers further examined the data on actual solar flares, they discovered that something else was happening. Furthermore, the explanation was both unexpected and even unremarkable to some extent. In essence, the boundary between regions of low and high density plasma is where the downflows that are seen on solar flares occur. The two are like oil and water where they meet. They don't mix because of their distinct densities, but they do create tiny ripples and bubbles at the boundary. Fluid dynamics is ultimately responsible for how exactly these ripples turn into those dark spikes, despite the complicated physics involved. Those dark spikes are voids in and of themselves, with significantly less plasma than the surroundings. And they appear as a result of the interactions of fluids with various densities when they come together. In other words, not precisely a lava lamp, but also not a lava lamp. The group published its findings in Nature Astronomy in 2022. After more than 2 decades following the 1999 discovery of these puzzling downflows, scientists now had a decent understanding of what was producing them. The solution goes beyond resolving the nagging problem that has plagued astronomers since 1999. Understanding solar activity helps us better monitor space weather and handle the risks associated with being in the orbit of a blazing ball of gas. Do not forget to like, share and subscribe to our channel, Explified.